Hello everyone, this is Dr. E, and for today we're going to be working on special case of binomials and how to multiply them. From our previous lesson, we are able to classify polynomials according to its number of terms, and for today we're going to be working on special cases of binomials where we can introduce a different method on how we multiply them. So special products would entail that we have alternative way on how to multiply special cases of binomials. But first, let's discuss about the FOIL method, which is the common method that we use when we multiply polynomials. So when we multiply two binomials, the distributive property can be easily remembered as the FOIL method, which is the acronym for F, or product of the first terms, O, which is product of the outside terms, I, which is product of the inside terms, and L, which is product of the last term. And we're going to use this method in multiplying binomials like example 1 and example 2. So let's start with the first example, which is multiplying y minus 12 by y plus 4. Now, using the FOIL method, which is basically first, out, in, last, that means we're going to distribute the first terms, which is y squared, distribute the outer terms, which is y times 4, and y times 4 is positive 4y. Inner, which is negative 12 times y, so we have negative 12y. And last terms, which is negative 12 times positive 4, which is going to give us negative 48. And from here, we can still simplify our polynomials because by combining like terms, 4y minus 12y will give us negative 8y, and y squared and negative 48 is just going to be the same terms because there's no more reason to simplify y squared minus 8y minus 48 because there's no like terms anymore. So this will be our product for y minus 12 times y plus 4 using the FOIL method. And if we multiply 2x minus 4 times 7x plus 5, of course, we're going to still use the FOIL method. So if we have 2x minus 4 multiplied by 7x plus 5, using the same technique, 2x times 7x is going to be 14x squared. Outer would be 2 times 5, which is 10x positive. Inner, which is negative 4 times 7, which is negative 28x. And last terms, so we have negative and positive is negative. 4 times 5 is equal to 20. And by combining like terms, we'll be able to have 10 minus 28x simplified into negative 18x. And by bringing down 14x squared and negative 20, we now have the product of 2x minus 4 times 7x plus 5 as shown in our solution using the FOIL method. And these methods will always work when we are multiplying not just binomial, but any type of polynomial. But for this lesson, we're going to be introducing the special case of binomials, which is squaring a binomial. And if we square a binomial, we'll have a plus b quantity squared and square of a minus b, which is equal to the first product would be a squared plus twice of ab plus b squared, and a minus b quantity squared would be a squared minus twice of ab plus b squared. And by using this formula, we'll be able to still find the product of the two binomials. So let's start with working with these two examples right here, and we have x minus 6 quantity squared and 5x plus 3z quantity squared. So if we encounter binomial that is squared like so, please don't make the common mistake that most students do, which is to distribute the square and think that this will equal to x squared minus 6 squared. Please remember that this is not equal to this, and this is an illegal move in algebra. So when you see x minus 6 quantity square, it's actually simplified by expansion. And when we say expansion, we're just going to have twice of x minus 6, and we're going to multiply them. And we can multiply this using the FOIL method, but for this time, since we're seeing a square of binomial, we can use our pattern for this particular special product, which is a minus b quantity square is equal to a squared minus twice of ab plus b squared. And how we're going to use that? We know that a is equal to x and b is equal to 6. All we need to do is to replace a with x, and b with 6. So we'll have 6 quantity square at the very last term. And by simplifying our polynomial, this will give us x squared. This will give us 2 times 6, which is negative 12x. And this will give us positive 6 squared, which is 36. And now we have the product for x minus 6 quantity squared, which is the same as what we have in our screen right now. So with this, we're able to use the formula or this special product for these binomials. And let's see if we can also apply this to our second example, which is going to be 5x plus 3z quantity square. And in this case, we're going to be using a plus b quantity square. And according to the formula, a plus b squared, or a plus b quantity squared, is square of a plus twice of ab plus square of b. So that means a is equal to 5x and b is equal to 3z. And by using these terms, we will replace a with 5x and b with 3z and 3z squared. And you're not seeing the last term, but you know. Okay, let's rewrite it again so that everyone can see it. So we'll have quantity 5x squared plus twice of 5x plus 3z plus 3z squared. All right, now it fits. And all we need to do now is to simplify our terms by squaring 5x. And the common error that most students do when we square terms like this is they forget that they need to square the numerical coefficient as well. So 5 squared is equal to 25. And x squared is equal to x squared. So this is the correct square of 5x plus 2 times 5 times 3. 2 times 5 is equal to 10 times 3 is 30. So we have 30xz plus square of 3 is 9. And square of z is z squared. And from here, there's nothing else to combine because all of them are unique terms, not like terms. So this will be the final answer or final product for 5x plus 3z quantity square, which is the same answer as what we have on the screen. And we're able to perform the special product formula for these examples because they're both square or binomial square. One is a minus b quantity square and one is a plus b quantity square. And we have another special case of binomial, which is called the sum and difference. And in this special pattern, when we multiply a plus b times a minus b, the product will equal to a squared minus b squared. And this will be what we're going to be using for our second type or special case of our binomials. So remember, the sum and difference formula will give us a plus b, or the product of a plus b and a minus b is equal to the square of a minus the square of b. That's how simple it is. So let's see if we can multiply 5a plus 3 times 5a minus 3. Now, the first thing that you need to do is to check if this binomials qualify as the sum and difference of two binomials. And yes, it is the same pattern as a plus b times a minus b. So that means our product will simply be a square minus b square, or the square of a and the square of b. And in this case, a is equal to 5a, b is equal to 3. So that means this, when we multiply this, is simply going to give us square of 5a minus square of b. And 5a squared is not 5a squared, but 25a squared, and square of 3 is going to be 9, and this is going to be the product of our binomial for this particular case of difference of, or sum and difference of two binomials. So we have 25a squared minus 9, which is the same answer that we got from our computation. Now, is the FOIL method going to give us the same result if we use the FOIL method for this binomial? And the answer is yes. So let's see, using the same binomial, and let's use the FOIL method for the product, or finding the product of these two. So first, outer, which is 5 times negative 3, negative 15a. Inner, which is positive 15a. And then last term, which is positive 3 times negative 3 is negative 9. And we know that we can simplify this, and negative 15a plus 15a is going to equal to 0. So that means our product is 25a squared minus 9, which is the same as the product of our first work right here. So this is how we use this special case of binomial. So remember, you just need to make sure that your binomial qualifies to those special cases so you can use this method. Let's see if we can use any of the special method that we have for x minus 6 times 5x plus 2. And we know that we cannot use those special cases because they don't fall under the sum and difference formula and the square of binomial. So for this particular case, we have no other option but to use the FOIL method to find the product of x minus 6 and 5x plus 2. So by using the FOIL method, we'll have 5x squared, we'll have 2x positive, we'll have 30x negative, and we'll have negative 6 times 2, which is equal to 12. And by combining like terms, we have 5x squared. 2x minus 30x is negative 28x, and bring down negative 12. And now we have our product for this particular binomial. No special formula for this particular problem because it did not fall under the special cases of binomials that we've just covered for today's lesson. So remember, when you're working with binomials, if let's say you forgot how to use the formula for those special cases, you can always revert back to the FOIL method to multiply the binomials and your answer will still be the same. But for your Numberbender challenge for the day, I want you to start getting used to the pattern of using the special cases of binomial and see if you can find the product of 12a minus 3 quantity square without using the FOIL method, but using the special case of binomial that we covered for today's lesson. And that is our lesson for today in algebra, using our special cases of binomial to find the products of those patterns. And it's all about pattern recognition in mathematics, and to be able to recognize patterns quickly and easily, it takes practice to master a skill similar to what we did today. This is Dr. E, and keep on practicing. Bye!